Let's go into a little bit more detail now about heart valves. So we're going to start by discussing the function of these valves. One of the major functions of these valves is to make sure that blood goes from the atria into the ventricles and not vice versa. You don't want blood flowing in the opposite direction. You want to then go through the outflow tracts in one direction. That sounds like a musical group. From atrium to ventricle, ventricle to some great vessel. Okay? That's its function. And there it is going off into the pulmonary circulation. Okay, so let's start by talking about atrioventricular valves because there's also semilunar valves, and so we'll talk about the two atrioventricular valves, tricuspid and bicuspid, and then the two semilunar valves, aortic and pulmonary. So let's go first with our AV valves, shall we? So here we have a picture of a coronal section through the heart, and in blue is the tricuspid valve, and then in red there's a bicuspid valve. Recognize blue, I did that because it's the valve between the right atrium and ventricle, which is deoxygenated blood, and then the bicuspid valve because it's between the left atrium and ventricle, which is oxygenated blood. So some of the anatomy of these valves. So what we're going to do is going to take that little area and then blow this up a little bit, and so now we're going to be looking at this illustration of an AV valve where we have the atrium above and the ventricle below. This is the right ventricle because there's three cusps, hence tricuspid, but it's the same for the left AV valve or bicuspid valve. Now there's that tricuspid valve. There's three cusps on top. And these papillary muscles are projections of the myocardium, so it's actually muscle and it contracts. And the purpose is those muscles are going to be attached to the AV valves via these heartstrings called chordae tendineae, which just means tendinous cords. And these tendinous cords attach from papillary muscles to the actual AV valve. And their function, the papillary muscles and chordae tendineae prevent prolapsing of these AV valves during systolic contraction. Now, what does that mean? All right, well, let's take a look at a schematic. So here we have the atrium above, and there's the ventricle below. There we have one of the cusps of this AV valve, and then there's the chordae tendineae attached to the papillary muscles, just like our previous illustration. Now, what happens is, during diastole, blood pumps from the atrium, shing, all the way down to the ventricle. Then during systole, it switches. Now the ventricles are going to contract and want blood to pump from the ventricle out through the semilunar valves. So we have to make sure that blood is not going to go from ventricle to atrium. So as blood is pumped and it reaches this area where the valve is, it shuts those valves. Then notice the papillary muscles attached by the chordae tendineae to those cusps prevent those valves from prolapsing back up into the atrium and blood to flow out. That's a function of these AV valves, okay? There we have them contracting, keeping those valves down. Now the sound, whenever this happens, bam. So whenever those AV valves slap shut, they make a sound. It's the first sound in the lub-dub. Remember people talk about the sound that heart valves make, lub-dub, lub-dub, lub-dub. Well, the lub sound is what we call the first heart sound, or S1 for sound 1. And that is the closing of the atrioventricular valves. These valves, the two AV valves, are the tricuspid because this is an axial section through the heart. We've removed the atria, right and left atrium, and the main body of the aortic arch and the pulmonary trunk. So on the right-hand side, there's our 2 and 3 cusps, okay? There's anterior, posterior, right, and left. And so that yellow circle surrounds our tricuspid valve. Try to be right. That's how I always remember. Try to be right. And that's how I remember the tricuspid valves on the right side. Okay, now bicuspid valve. That has 2 cusps. There's one cusp and there's another cusp, okay? And so that's bicuspid valve. Now, let's take a look at semilunar valves, shall we? All right, so our semilunar valves are the ones that are the pulmonary valve, and then there's pulmonary valve, and then the aortic valve, which is right there. So the function of these valves is also to prevent backflow. So let's show this picture. So there we've got our ventricle below, and there we have the pulmonary trunk or aorta above, because right ventricle pumps blood to the pulmonary trunk, left ventricle pumps blood through the aorta. And so the arrows are going to go in an opposite direction through that semilunar valve, because now during systolic contraction or systole, the ventricle contracts and pumps blood up. So here we're going to take the left ventricle, and there's it down below in the aorta above. So when blood is pumped, it goes woo right through those valves. And we want it to, right into the aorta. Hallelujah. But once it goes up into that aortic arch, just it comes to the top, and then you have blood flow that then backflows when the left ventricle relaxes, and then that blood forces those valves shut, and that's how we get the closing of that semilunar valve. Now the sound. So what happens when this thing closes, it makes a slap shut as well. And so the second sound, lub dub, is this S2 or second heart sound. So in listening to, using a stethoscope and listening to heart valve sounds, S1 is the closing of the AV valves, S2 is the closing of these semilunar valves. So the pulmonary valve is more anterior, in contrast to the aortic valve, which is more posterior. Another way you remember this in an axial section, so that the pulmonary valve is more anterior, aortic valve is more posterior. But also, take a look at this. Only on the aortic valve, we have the right coronary artery coming off the right cusp, and then the left coronary artery coming off the left cusp. And that's another way of telling the aortic valve from the pulmonary valve. It's got the two coronary arteries that come off.